Today we will solve a question, and the question reads, which compound has the highest boiling point? And the four options are option A, propane, option B, ethyl chloride, option C, methanol, and option D, acetic acid. So we will get straight into the solution. Whenever the question is about the boiling point, so it is all about the relevant concept of intermolecular forces. So out of all these four compounds, we have to find out which has the strongest intermolecular forces so that it requires a very high temperature or very highest boiling point for it to reach the boiling point. When we consider the compound A, it is non-polar. It is a non-polar hydrocarbon chain. So the forces in them is van der Waals forces, and therefore it is very quite weak and has a very less boiling point. And in case of ethyl chloride, it has a formation of a dipole. It has a formation of a dipole, but it is quite weak as well. So it has a dipole-dipole interaction. So it is a dipole-dipole interaction. And in case of compound 3, it has a hydrogen bonding. In case of the compound 3, so in case of CH3OH, it has an hydrogen bonding. So it is in fact stronger than the compound A's van der Waals forces and compound B's dipole-dipole interaction. And when we consider the compound T, which is CH3C double bond O OH. So this fosters a very strong, extensive hydrogen bonding. This has a very strong, extensive hydrogen bonding. So when we compare the compound D with all other A, B, C, it is very clear that it has a very strong hydrogen bonding, and therefore it has the very high boiling point. So if we have to summarize the order, so it is always the van der Waals forces or the London dispersion forces. Sometimes it is otherwise called as synonymously. So the van der Waals forces is the weakest, and the next comes the dipole-dipole interactions. Dipole-dipole interactions, and then followed by it is the hydrogen bonding. So when it is compared between the CH3OH methanol's hydrogen bonding, the hydrogen bonding of the acetic acid is quite high because it can form a dimer. Therefore, the highest boiling point is featured towards acetic acid.